All right, we're going to go ahead and continue with our Vesper theory. Now we're going to cover sp2 and sp today. I'm going to try to move a little bit quicker. Hopefully we can get to some orientations at the end that might be a little bit different. If not, we'll have to cover them in class. All right, so with sp3, we had 4 branches coming off of it, whether it was electrons or actual elements that it was attached to. sp2 is going to have 3 branches coming off of it. So it's going to have a central atom and 3 things coming off that way. Now, when we work through this, that's going to give us a bond angle of 120 degrees. Now that doesn't matter what orientation it is. As far as they get away from each other, it's going to end up being 120 degrees. So this is a flat object. This is in one plane. So this is called trigonal, 1, 2, 3 things, planar. So that's a new shape for us, sp2 trigonal planar. So let's take an example of how, take a look at an example of how we get to sp2. One example of sp2 is going to be, let's say C2H4. Okay, that is going to be an organic compound called ethene. Okay, I have a double bond, 2 hydrogens, 2 hydrogens, 2 hydrogens. Okay, that's what it's going to look like. Now I am going to take a look at just one specific carbon at a time. Okay, I don't want to look at the whole picture because the whole picture just tells us way too much. So I have multiple bond angles here, only one that I'm interested in right now though. So I'm going to take a look at this first carbon. Okay, so I'm going to get rid of this over here. Okay, so how do I know that I've got a double bond, or why am I going to have a double bond? Let's go back a step and figure out how we get that. Okay, we know carbon has 1, 2, 3, 4 electrons. Okay, hydrogen can only bond one time, so I don't want to mess with the hydrogen until I'm all the way done or nearly done. Okay, I have another carbon that has 1, 2, 3, 4. Okay, so if I have hydrogen over here, it can bond one time. So let's bond it. And for giggles, I'm going to bond it right there. Yes, I know it's ugly right now, but I'll come back and fix it, make it look pretty. Then I have hydrogens over here. It has 1 electron, so I bond it. And 1 electron, so I bond it. Okay, this carbon, if I count the bonds or the electrons that I have 1, 2, 3, 4, 5, 6. Not good. This one has 1, 2, 3, 4, 5, 6 as well. Also, not good. Okay, I have 1 bond here. Okay, now that gives me 7. And 7, guess what? I have another one. I can bond that. Okay, so I'm going to clean it up, make it look like what we had a little bit earlier. And there we go. Okay, that is our sp2 trigonal planar. Okay, now there is a couple instances where I might have a free electron pair right here. Okay, in that case, this bond angle would no longer be 120. It would be a little bit lower. I'm not expecting you to remember what that is. But if you did have a case where you had a free electron pair, mostly it'll happen with ions. It'll drop below 120. All you need to know is it's below 120. Okay? All right, the next one is sp. You will notice, by the way, back to the sp2, we added something new. Most of them have double bonds. Not all of them, but most of them. All right, sp. Okay, not 4, not 3. It's got 2 things off of it. Great example of that would be our buddy carbon dioxide. Okay, so carbon has 1, 2, 3, 4 coming off of it. Okay, oxygen, 1, 2, 3, 4, 5, 6. And I just start bonding away. Okay, When I bond those right there, that makes oxygen happy. Carbon's not happy. This one's not even close to being happy. So let's try to make it happy. Okay, so I just keep adding. Now this oxygen's happy, carbon's happy, this oxygen's happy. Sometimes if I'm really starting to work through these, I'll make sure each individual one is happy or as happy as they can be. And in this case they are. Now, shape-wise, I have a central carbon atom. Since I only have two, as far apart as I can get is going to be 180 degrees. Okay. These are called linear. They're in a straight line. Okay, so we have a linear molecule. In this case, it's CO2. It's linear. Now, sometimes they're going to ask you things like, what is the orientation for oxygen? And at first glance, you might think that oxygen doesn't have an orientation. But you see over here, oxygen has three things coming off of it. Okay, so the electron pairs plus this, that's an orientation. We can read that. This is an sp2 orientation, even though the carbon is an sp1. All right, that was a little bird walk. I'm going to get back on. Okay, with a linear thing, that is all I can have with it. I'm not going to have a smaller piece of it. It's just going to be one straight line, and we're good to go. All right, we're going to check to see how much time we have. If I'm back, we're going to come back. All right, coming back at you, we're going to talk about sigma bonds and their importance. I don't know if we'll have time to get to pi bonds today, but if we do, that's awesome. All right, so we remember back. We're going to go back a little bit. This is our s orbital. Remember, it's a spherical shape. Each s orbital can hold 2 electrons. It's going to be important to us. P orbitals, each p orbital can hold 2 electrons as well, but I'll have 3 p orbitals, one going this way, one going up, and then one coming out towards you. So we have x, y, and z p orbitals. Okay, we're going to take those. We talked about the hybrids. We're putting them together. Okay, this is an sp3 hybrid orbital. Okay, the s came over, or the p moved over, both of them squished together, and here is our sp3. It's got 4 different spots. Okay, when I look at this, so carbon has 4 electrons. Okay, when I add hydrogens, let's say this is a carbon right here. When I add hydrogens to them, okay, hydrogen is still an s. It's not a hybrid orbital. It's going to come over here. He snuggles up there. We add an electron. He snuggles up over here. We add an electron. This is the one that's going back into the board. Don't gripe about my drawings. Back there. And we have another one up here. Okay, so that's how we end up with a full octet of electrons, because we have this hybrid orbital in the middle, and then we have these regular orbitals to the edge, and they're going to help things out. Okay, so that is an sp3 hybrid orbital. That is how we get there. All of these bonds are what we're going to refer to as sigma bonds. Okay, I draw it as a little guy with a little hat on top of his head. I know some people will draw it lots of different. They said capital, cursive S, whatever. I don't care. That's how I draw it. If you don't like it, deal with it. So that's my sigma. Every time we see a single bond, we will call it a sigma bond. Every time we see a double bond, we have 1 sigma bond. Every time we see a triple bond, we have 1 sigma bond. It's going to come back quite a bit. So this is going to be our sp3. Here in just a second, we're going to go to sp2 and hopefully sp.